This section, we're going to talk about algebra and their functions. So we've been talking about functions. If you want to take just a moment, pause this so you can read this. These are our objectives. But when we talked about functions, I said they can have different names. We can call them f of x, g of x, h of x. Now we're going to talk about taking two different functions, two different names, in respect to x, that's going to yield me out some y outcome. And we're going to use the sum, the difference, the products, and the quotient functions. Basically, we're going to add, subtract, divide, and multiply functions of the two given functions. In this case here, we're going to use f for one name and g for the other name. And if you'll see right here, if we have an addition of f of x plus g of x, let me give me a second, get the highlighter going. Then we're going to get f of x plus g of x. And it also can be written this way, right? So it's showing you two different notations for the same work. If I have f minus g of x, it's the same as saying f of x minus g of x. If I have f times g of x, that's the same as f of x times g of x. If I have f divides g of x, then that's the same as saying f of x divides g of x. Now remember, the denominator cannot have 0, so that's why it says the g of x function cannot equal 0. If the f of x function would have been in the denominator, it would have said f of x couldn't equal 0. All right, so let's move to the next slide. All right, so we are giving f of x is equal to x plus 1. Let me highlight it. We're given this. And we're also given where g of x equals the square root of x plus 3. Now, when we get to the section, when we start talking about domain and range, we'll dig a little deeper into this. This here cut off the print, so I'm just going to write it for you, okay? Okay, so part A says, let's add those two functions. I know that it's worked out here, but I'm going to go ahead and work it out so I can talk through it. So let me just double check because it's saying that our function is missing. What are we missing here? And I apologize, guys. 1 second. I didn't catch that would ago, or I would have wrote it down for you. It said, oh, okay, because if you notice, we got 3f plus g functions. So it said we're going to let the first one be in respect of x. The next one's going to be, we're going to replace x with 6. And then the third one said, let's replace x with -4. Okay. All right, -4 right here. Okay, so what we're going to do is we're going to take our f function and we're going to add it to our g of x function, right? So I got x plus 1 plus the square root of x plus 3. However, whenever you add or subtract, you have to have like terms. I have x to the first here. I have a constant. Then I have a square root of something. So these are not like terms, so I cannot put them together. So that would be my answer for A. So what I'm going to do is I'm going to take that here and let's solve. And I apologize, my computer is messing up my screen. Hopefully you can follow this. Let me change this. Maybe this will help if I change the color. So I'm going to take that f plus g, which gave me x plus 1 plus the square root of x plus 3. And I'm going to plug 6 in everywhere I see the x. So I got a 6 here and a 6 here. Let me finish this out. All right. So now I have 6 plus 1 is 7 plus the square root of 6 plus 3 is 9. And the square root of 3, or excuse me, square root of 9 is 3. So I have 7 plus 3. And this is equal to 10. So for B, when f of x plus g of x with the given functions in respect to 6 equal and x, we yield out an answer of 10. Okay. So if I wrote it in order pair, I would have had 6, 10. Okay. The next one here says we'll take the same functions. Let's plug in -4 for x. So I'm going to put in -4 here and -4 here. And now I got +1 plus. All right, so -4 plus 1 is the same as saying that my bank account's in a -$4. I deposit $1. Now I'm at a -3. I got -4 plus 3. So this says that I'm in the whole $4. I deposit 3. I'm in the whole -1. All right. So let's talk about this. We are working with an even root. And whenever we're working with an even root, we know that an even amount of times would not yield out a negative answer, right? Oh, please forgive me, I left off the plus sign right here. Here, okay. So this is technically an imaginary number. And now, if it would have been a cube root, which is an odd number, or a fifth root, or whatever, a -1, well, we can come out with -1. And what am I saying? I'm saying if I took -1 and times it by -1, since this is a square, you do it twice. It's saying that we would come out with a -1 answer in this statement, which is not true. So this one does not exist. And if we was to acknowledge it existing, we'd call it imaginary. Now over here, if I had the cube root of -1, this is the same as saying -1 times -1 times -1 gave me -1. Well, this is true. You can multiply and anything an odd amount of times or excuse me, let me rephrase. When you take a negative number and multiply it an odd amount of times, you will come out with a negative answer. But you cannot take a negative number and multiply it an even amount of times and come out negative. So in C, we're going to say this does not exist. Okay. And you'll see on these worked out slides here, they'll tell you. All right. Now let's talk about domains of f plus g, f minus g, f of g, g, or f times g, and f divides g. So, and I'm going to fill in some of the spots that are missing the letters here. So what it's saying is if f and g are functions, then the domain of the functions of f plus g, f minus g, and f times g is the intersections of the domains, right? So of f. And because the reason why it's of f is because it said f plus it. And we'll get to composition functions soon too. All right. Now, when we talk about the division part, we are definitely going to look at what's in the denominator to determine our domain. Okay. So example 2, it says that we are given a function f of x is equal to x squared plus 4, or excuse me, minus 4. And then we are given a g function equal to x plus 2. And we want to find the following. So we want to find all of the pluses, minus, multiplication, and division of the f and g. And then it also wants us to state the domains of it. So I look here and I have a polynomial for the f function and a polynomial for the g function. So we know these are going to be all real numbers. What you want to look for is fractions. If you have a variable in the denominator, then there's going to be a restriction, and that's where we're going to look at for our domain. If we have a even root, then we're going to take that variable and set it greater than or equal to 0 and solve for it, and then we'll have our domains, we'll have our restrictions. A polynomial is all real numbers, no restrictions, because you can come out with negative and positives. An odd root, which like I showed you a while ago, the cube root, fifth root, and so on, There is no restrictions. It's all real numbers. So this is what this information is just letting you know. But let's go ahead and solve. And let me pull up a Word document right quick. I can get me a blank one. And let's solve these, okay? It gives me more room. Let's do the F plus G. Now you gotta watch the order. It could have said G plus F. That would change it up. So definitely watch for that. So my F function, which you're going to see this notation, the F function that was given us was x squared minus 4. And we're going to add it to our G function of x plus 2. So now I'm going to look on what you want to do whenever you have something in parentheses, you want to look in front to see if there's anything in front of it that you're going to distribute it into the parentheses that's going to change it. And we don't. So we're going to, because it's just +1, we just don't write it there, right? All right, I'm going to drop the parentheses and I'm going to put x squared minus 4 plus x plus 2. And now I want to put together any like terms. And I noticed the constants can be put together. So I got x squared plus x. This is saying that I had $2 in my bank account, but I spent 4, so I'm in the hole $2. This would be my answer for the plus. Now let's do F minus G, and again, the order matters, so you got to write it how you see, or how it's seen, or how it's given to you. All right, so my F function is x squared minus 4 minus, because it said subtraction, a G function of x plus 2. So before I drop my parentheses, again, I'm going to look in front of this and see if there's anything here to be distributed. It's going to change it. Same here. Well, the first parentheses, nothing's going to change it, so let's drop it. But the second one, I got this negative sign that I'm going to distribute. So negative times positive is negative, negative times positive is negative. Now let's put together any like terms. I see that I have x squared minus x. My only like terms are my constants. It says we're in the hole $4 and we spend 2 more, so we're in the hole $6. So here's my subtraction. Okay. Now let's go to the multiplication of it. It said F times G of x. So I'm going to take my x squared minus 4 times x plus 2. And since it's multiplication, I'm going to go first times first. I'm going to say outers times outers. And then I'm going to say inners. And then I'm going to say last. All right, I'm going to come over here and just kind of rewrite it neater. So now I have x squared times x. And whenever you multiply bases, like bases, and you agree they're both x's, you're going to add the powers. So I got the x squared on the first term there being multiplied to the x that has only a power of 1. So I'm gonna do an extra step, so y'all do not have to, but I'm going to do it. And then my next one says I have 2x. So let's write that down. So plus 2x. The next one I see is a negative 4 times x. So I got a negative 4x. And then I have my last one says I got a negative 4 times positive 2, which is a negative 8. So now let's clean it up. We're going to put together these two terms because they are like terms. The rest of them are not. And we want to clean this up. So I got 2 plus 1 is 3. This says that you have $2, but you spent 4. So we're in the hole $2 minus my 8. And this is my multiplication. Oh, it's my multiplication, yes. All right, so now let's do our division. It says take F and divide by G. So my F is x squared minus 4 over x plus 2. So let's rewrite it. We have a difference of squares up here in the top. So I'm going to have x minus 2 times x plus 2, all divided by x plus 2. Now, if you're unsure about this, there's another way of factoring that. So let me just do an extra step for those of you that are unsure, okay? Before I clean this up. So I can look at this x squared minus 4. And if you agree, 4 is a perfect square of 2. And then x squared, a perfect square of x. Meaning I can say, oh, x squared minus 2 squared. Right? This minus tells me I have a difference of signs. So this can be written in factors of x minus 2 times x plus 2. That's one way to look at it. Another way would be I can factor out those. But this is a difference of perfect squares. If you want to check your work, you can say, oh, x times x, which is x squared, x times positive 2, x times a negative 2, and negative 2 times positive 2. These two go to 0 and leaves me with x squared minus 4. So there's multiple ways to look at this. I hope one of the methods help you. If not, please reach out to me. I'll be happy to go over this with you, okay? So let's finish this. I noticed that I got x plus 2 over x plus 2. They go into itself once, leaves me with 1 over 1 here, 1 times that x minus 2, and this is my final answer. Sometimes when you do the division one, it will reduce. Sometimes it will not. And guys, I just noticed on the multiplication, what did I do wrong? So I apologize to you right now off the bat, and those who caught it, kudos to you. What happened is, let me change this right quick so I could show you what happened. When I took this one here, maybe I could do this. When I took this first term and I multiplied it to this this first term, I came up with x cubed. That's correct. However, when I took this first term and I multiplied it out here to this outer term, right? That's right here. What happened? I left off the square on the 2 or on the x. So that goes here. So what does that tell me? That tells me it does not combine with this 4x. So this is actually about as clean as this is going to get. So whoever caught this, kudos to you. I'm going to rewrite it just one more time because of that 2 plus 1 on that power. So just know we're all human. We do make mistakes. I get in a hurry sometimes. I just have to go back through, and that's what I was doing. While I was talking to you, I was going back through just to look, because it didn't look right when we started out with an x squared. I knew that, and then an x to the first, and knew that we had to have a cube and a square involved in their answer, and I didn't see it. So, again, if you have any questions, just feel free to reach out to me. All right, so now let's go to our next slide. And on this one here, it has it, if you want to pause it to read. And here it is worked out. So they said that it came out with x squared. Let's look at that. So when I did this, I distributed the negative to these two here. So now we got x squared minus 4 minus x minus 2. This here, okay, so what happened was it didn't fully load the answer here. So I want to finish it out. So those of you that are pausing this, you don't get it wrong. So I have minus x, and then these two here, it goes together, get negative 8. Okay. Okay. Yay. Looks great. And the division one. So yeah, I wrote this down a while ago. Let's see. We have x squared minus 4 over 2, or x plus 2. There you go. And then these two reduced. All right, looks great. And I didn't see where it asked us to do the G times G, but we could do that. So if we have G times G, if that's what was asked, and sometimes they tell you some value for X, and when they do, when you get down to the bottom after cleaning it up, plug in that value for X, or you could plug in at the beginning. It's up to you. This is the same as G of X times G of X. Since we're multiplying the same two, we can say, oh, well, G of X squared. And that's what they did here. So this here says we got X plus 2 times X plus 2. And then you could do the full method. X times X is X squared. X times the outside plus 2X. And now we're going to say 2 times X, which is 2X, and then 2 times 2, which is 4. And now we got X squared plus 4X plus 4. Okay. So now let's go to our next slide. Oh, difference of quotients. I like this one. Just be careful when you work these, work them in parts. So whenever we do the ratio below, we're going to be talking about a difference of quotients. It's average rate of change is another way of saying it. And if this looks familiar to you, it's basically where we took the sum of them all and then add them up. Well, we have a difference between quotients, and we do have the average rate of change because we're going to divide it by. Okay, so let's solve our next equation. Actually, I want to write on this. I'm going to just write the problem here. These are kind of fun, I think. I mean, in my opinion, they are fun, okay? I'm not going to say you're going to like it, but. So what do we got here? We are giving f of x is equal to 2x squared minus x minus 3. All right, so step one, this is what I would do. I would do it in parts. If you don't want to, you don't have to. But if you notice that it says take f of x plus h, and we're going to subtract it from our f of x. Well, we got our f of x right here. So this is going to go right in here. However, we got to figure out what is x plus h. So we're going to take our f of x and we're going to plug in the x plus h in the place of x. So now I have 2 times x squared minus x minus 3. And let's plug in what we know. Well, we know that it is x plus h and x plus h in for x. So now let's go ahead and rewrite it. I have 2 on the outside, but I got x plus h squared, so that means I'm going to multiply it to itself twice. And I'm going to distribute this negative sign, and negative times positive is negative, and bring down that negative 3. Now, I want to full this out. I got my first times my first. I got my outers. Plus, I got my inners. Plus, I got my outers again, or my last. I'm doing extra steps, guys. You do not have to do these extra steps, but I am. And clean up my writing right here. Kind of messy looking. All right, there we go. And now I'm going to bring all the rest of the stuff around. Now remember, we're only looking for this part right now. All right, let's finish this up. X times x is x squared. And then xh plus xh plus h times h is h squared. These two can be put together because they're like terms. So xh plus xh is 2xh plus that h squared. Now let's distribute the 2. So now I got 2 times x squared, right? Now I got 2 times 2xh. And then I got 2 times h squared. All right. Now I want to bring down this next part where it says minus the f of x function. The f of x function is 2x squared minus x minus 3. And it's all divided by h. So if you want to go ahead and put that underneath it, I would. If that's what you want to do, let's do it. All right. What we want to do is distribute this negative sign so we can drop the brackets to everything inside it. So let's do that. So now I got 2x squared plus 4xh plus 2h squared minus x minus h minus 3. Negative times positive is negative. Negative times negative is positive. And then negative times negative is positive. All divided by h. Now, before I go any further, I want to look to see if there's any like terms. Or not so much like terms. Is there anything I can put together? Yeah, like terms, sorry. Can I put anything together, right? So I got 2x squared. I positive 2x squared, and I got a negative 2x squared. So those two go to 0, right? Because it's like saying you have $2, you spent 2, it's gone. I have a negative x and I have a positive x. Those two go away because it's like saying you had $1, but you spent it. I have a negative 3 and a positive 3. So those go away. They go to 0, right? It's basically saying you had $3 and you spent them all. If you can cancel out your original function, which was the 2x squared plus x plus 3, if you can cancel, or excuse me, it was minus x minus 3, I believe. Let me just double check and I didn't write it down wrong. Yeah. Minus x minus 3. So if you could do that, then you know you set this up right. So now what I'm going to do is take the remaining and say 4xh plus 2h squared minus h, all divided by h. If you wanted to, you can break it in parts or in terms, because there's 3 terms divided by the same denominator. So we can do it like this if it makes it easier for you. And now we say, oh, okay, I have h that goes into h one time. I have h that goes into h squared, leaves me with just a h. And then I got h that goes into h once. Sorry about my puppy. She thinks she heard something. Okay, so now I have 4x times 1 over 1 is just 4x. And I have 2h, a positive 2h. And then I have 1 over 1, right? Because h went into itself once and a negative there. So my answer is a minus 1. And this is my answer. So these are pretty fun. You may have to take your time with them. And then here it is. It worked out for you. Okay. It's worked out some more. All right. Thank you.